good evening, and welcome back to Science for Sleep. Tonight we are exploring one of the most unsettling questions in science and philosophy, a question that touches the deepest parts of identity, a question that asks something extraordinary. What if the choices you make today were already determined, nearly 14 billion years ago? What if the moment you decided to watch this video, the moment you chose what to eat today, the moment you spoke your last sentence, was already mathematically inevitable since the beginning of the universe? At first, that idea sounds impossible. After all, every day we feel like we make decisions. We choose. We evaluate options. We change our minds. We believe we are free. But some physicists and philosophers argue something very different. They suggest that the universe may operate like a vast unfolding equation, a system where every event follows from previous conditions, a cosmic chain reaction that began with the Big Bang itself. And if that is true, then every decision you will ever make was already written into the initial conditions of the universe. Tonight we will explore the science behind that possibility, not through speculation or science fiction, but through physics, mathematics, neuroscience, and philosophy. We will explore deterministic physics, quantum uncertainty, chaos theory, information theory, and the strange idea that the universe may be computing its own future. But do not worry, this is not a lecture. This is a quiet journey through one of the deepest mysteries ever considered. So take a slow breath, allow your body to relax, and let us begin at the very beginning, the birth of everything. The universe begins with one equation. Nearly 14 billion years ago, the universe began in an event we call the Big Bang. This was not an explosion in space. It was the expansion of space itself. At the earliest measurable moment, the universe was incredibly small, incredibly hot, and incredibly dense. Every particle that would ever exist, every atom, every galaxy, every star, every planet, every living organism, was compressed into an unimaginably tiny region. And from that moment forward, the universe began expanding. But expansion alone does not explain everything. What makes the universe predictable is something deeper: the laws of physics. These laws govern how matter moves, how energy behaves, how particles interact, and most importantly, the laws of physics appear to be consistent. If you drop a stone today, gravity pulls it downward. If you dropped a stone 1 billion years ago, gravity would have behaved the same way. The equations describing these laws do not change with time. And because the laws are consistent, physicists discovered something remarkable. If you know the current state of a system, and you know the laws governing it, you can predict its future. This idea is called determinism. And one of the earliest thinkers to explore it was a scientist named Pierre-Simon Laplace. Laplace imagined a hypothetical intelligence, a being that could know the position and velocity of every particle in the universe. If such a being existed, and it understood the laws of physics perfectly, then it could calculate the entire future of the universe. Every planet's orbit, every chemical reaction, every storm, every heartbeat, and every human decision. Laplace believed the universe might be like a giant clock. Once the gears began moving, everything that followed was inevitable. This hypothetical intelligence became known as Laplace's demon. Not a demon in the supernatural sense, but a metaphor for perfect knowledge. And according to this idea, if the demon knew the universe at the moment of the Big Bang, then it could calculate everything that would ever happen afterward, including you, including this moment, including the decision you will make tomorrow morning. At first, this idea seems terrifying, because it suggests something strange, that free will may be an illusion. But before we go further, we must ask an important question. Is the universe actually deterministic? Or is there randomness hidden inside reality? Now take another slow breath, because as we move deeper into this story, the universe becomes stranger. Much stranger than the neat clockwork vision imagined by Laplace. For more than 200 years after Laplace proposed his idea of perfect determinism, physics seemed to support it. The motion of planets could be calculated. The paths of cannonballs could be predicted. Chemical reactions followed precise rules. Everything appeared to obey mathematical equations. But at the beginning of the 20th century, scientists began studying something extremely small: the behavior of atoms. And what they discovered changed physics forever. Inside atoms, particles did not behave like tiny billiard balls following predictable paths. Instead, they behaved like waves, like probabilities, like clouds of possibility. The theory that emerged to describe this strange world became known as quantum mechanics. And at the heart of quantum mechanics is something called the uncertainty principle. This principle, discovered by physicist Werner Heisenberg, states something extraordinary. It is impossible to know both the exact position and exact momentum of a particle at the same time. The more precisely you measure one, the less precisely you know the other. This is not a limitation of our instruments. It is a fundamental property of reality. Particles do not have perfectly defined positions and velocities simultaneously. Instead, they exist in probability distributions. In other words, nature contains uncertainty built into its deepest level. And if the universe contains true uncertainty, then Laplace's perfect prediction machine cannot exist. Even with perfect knowledge of the present, the future cannot be calculated exactly, at least not at the quantum scale. For a moment, it seemed like this discovery might restore something we call free will. If the universe contains randomness, then perhaps human decisions are not predetermined. Perhaps our choices emerge from unpredictable quantum events inside the brain. But the story is not that simple. Because randomness alone does not create freedom. If a decision occurs purely because of random particle behavior, then that decision is not controlled by you. It is controlled by chance. And chance is not the same as choice. So quantum mechanics creates a strange situation. The universe may not be fully deterministic. But randomness does not necessarily give us free will either. Instead, we may exist somewhere between order and unpredictability. Now let us look deeper into the mathematics of this. In classical physics, the universe evolves according to equations of motion. For example, Newton's laws describe how objects move under forces. These equations are deterministic. If you know the starting conditions precisely, you can calculate the outcome. But quantum mechanics replaces exact predictions with probabilities. Instead of saying where a particle will be, the equations describe where it might be. And when a measurement occurs, one possibility becomes real. This process is called wave function collapse. For decades, physicists have debated what this means. Some interpretations suggest the universe is fundamentally probabilistic. Others propose that every possible outcome occurs in different branches of reality. This idea is called the many worlds interpretation. According to this interpretation, the universe constantly splits into multiple versions. In one branch, a particle moves left. In another, it moves right. Both outcomes exist simultaneously in separate universes. If this interpretation is correct, then every decision you make may exist in multiple versions. In one universe you chose coffee. In another, tea. In one universe you watched this video. In another you did something else. All possibilities unfold. But you experience only one path. And yet, even this interpretation does not necessarily restore traditional free will. Because every possible decision still follows from the underlying equations of quantum physics. The universe simply explores all outcomes. Now this raises another fascinating question. Even if the universe contains quantum randomness, does that randomness influence the human brain enough to affect decisions? Some neuroscientists argue that the brain is too large and too warm for delicate quantum effects to matter. Quantum phenomena tend to disappear quickly in complex environments. This process is called decoherence. Others suggest that microscopic randomness might occasionally influence neural activity. Tiny fluctuations could be amplified by complex neural networks. But even if this occurs, it does not mean decisions are consciously controlled. It simply means they are not perfectly predictable. So the debate continues. Is the universe deterministic, random, or something in between? And what does that mean for human choice? To explore that further, we must examine something unexpected, a branch of mathematics called chaos theory. Because even a deterministic universe can produce outcomes so complex that they appear random. And that complexity may hold the key to understanding whether the Big Bang truly determined every decision you will ever make. Now let your thoughts slow again. Because the next part of our journey reveals something remarkable about the universe. Even if the laws of physics are perfectly deterministic, the future may still be impossible to predict. Not because the universe is random, but because it is chaotic. To understand this, imagine something simple. Weather. Weather follows physical laws. The motion of air, temperature gradients, moisture in the atmosphere, all governed by equations of fluid dynamics. In principle, if you knew the exact position and movement of every molecule of air in the atmosphere, you could calculate tomorrow's weather perfectly. But in practice, this is impossible, because the system is too complex. Tiny differences in initial conditions grow over time. A change as small as a fraction of a degree in temperature, or a shift in air pressure the size of a whisper, can alter the entire evolution of the system. This sensitivity to initial conditions is known as chaos theory, and it leads to one of the most famous ideas in science, the butterfly effect. The metaphor suggests that the flap of a butterfly's wings could eventually influence the formation of a storm thousands of miles away. Not because butterflies control the weather, but because small changes can cascade through complex systems. Now imagine applying this idea to the entire universe. Every particle interacts with others. Every interaction influences future interactions. From the earliest moments after the Big Bang, tiny fluctuations in density shape the structure of galaxies. Those galaxies form stars. Those stars created heavy elements. Those elements formed planets. Those planets created conditions for life. And eventually, one small planet developed beings capable of making decisions. So in one sense, your existence traces back to microscopic fluctuations in the early universe. Tiny variations in density. Quantum fluctuations in the earliest moments of cosmic inflation. These fluctuations were amplified over billions of years. They shaped the structure of the universe itself, which means something extraordinary. The galaxies above you tonight, and the neurons firing in your brain, are both consequences of the same ancient cosmic conditions. But chaos theory adds another twist. Even if the universe follows deterministic equations, its complexity may make prediction impossible, because you would need infinite precision to know every starting condition, and infinite computational power to calculate every interaction. No physical system could achieve that, not even the most advanced computer imaginable. In other words, even in a deterministic universe, the future may remain unpredictable, not because it is random, but because it is too complex to calculate. Now consider the human brain. The brain contains approximately 86 billion neurons. Each neuron forms thousands of connections with other neurons. These connections create networks of extraordinary complexity. Every thought you have, every memory, every emotion, every decision, emerges from patterns of electrical activity moving through this vast neural network. And those patterns are influenced by countless factors: your genetics, your past experiences, your current environment, your body chemistry, your sensory input, your memories, your expectations. Even tiny differences in neural activity can shift the outcome of a decision. And because the brain is such a complex system, it behaves in ways similar to chaotic systems. Small changes can produce very different outcomes. A brief emotional reaction, a random memory surfacing, a subtle environmental cue. These can alter your thought process in ways that are difficult to predict. This leads some scientists to argue something interesting. Free will may not require the universe to be random, nor perfectly deterministic. Instead, it may emerge from complex systems that are sensitive, adaptive, and unpredictable. In this view, human decisions are not predetermined like clockwork, but they are also not purely random. They arise from complex interactions within the brain, interactions shaped by both physics and experience. Now let us return to the original question. Could your decision today have been mathematically determined at the Big Bang? In one sense, yes, because the physical conditions that created the universe eventually led to the formation of your brain. But in another sense, the complexity of the universe may prevent any precise prediction. The chain of cause and effect is simply too intricate, too sensitive, too vast. Even if the laws of physics are deterministic, the outcome may remain effectively unpredictable. But there is still another idea we must explore. Because some physicists believe the universe itself behaves like an information processing system, a kind of cosmic computation unfolding across time. If that idea is correct, then every event in the universe, including your decisions, may be part of a vast informational structure. And understanding that structure may reveal something profound about choice, causality, and the nature of reality itself. Now let your breathing become steady again, because the final part of this journey takes us somewhere even deeper, beyond physics, beyond philosophy, into the idea that the universe itself might behave like a form of computation. To understand this idea, we must first talk about something fundamental: information. Everything in the universe can be described as information. The position of a particle, the spin of an electron, the arrangement of atoms inside a molecule. All of these represent states that can be measured and described. And according to some physicists, the universe evolves by transforming information from one state into another, just like a computer running a program. This idea became popular through the work of scientists studying information theory and digital physics. One famous phrase captures the concept: it from bit. This phrase was proposed by physicist John Archibald Wheeler. He suggested that physical reality may ultimately arise from information. Every particle, every force, every interaction could be understood as part of a massive informational structure. Now imagine the universe as a kind of cosmic program. At the beginning, the Big Bang, the universe started with an initial set of conditions: energy distributions, particle states, quantum fluctuations. From those conditions, the universe began evolving according to physical laws. Those laws act like rules in a computational system. They transform the state of the universe moment by moment, just as an algorithm transforms input into output. Over billions of years, those transformations produce stars, galaxies, planets, chemistry, life, and eventually, conscious beings capable of asking questions about their own existence. From this perspective, every event is part of a chain of information transformations. One state leads to another, then another, then another. If the rules remain consistent, then the entire history of the universe can be seen as one enormous computation. But here is where the idea becomes both fascinating and unsettling. In a computation, the output is determined by the input and the rules. If the starting conditions and rules are fixed, then every future step follows inevitably. This brings us back to the original question. Could your decision today have been determined by the initial conditions of the universe? Some physicists believe the answer may be yes. Not because someone planned it, not because the universe has intention, but because the unfolding of physical laws might make certain outcomes inevitable. Your brain is made of atoms. Those atoms follow physical laws. The interactions between those atoms create neural activity. Neural activity produces thoughts. Thoughts produce decisions. If every step follows from previous steps, then your decision may be part of a causal chain stretching back billions of years. But we must remember something important. Even if the universe behaves like a computation, that does not mean it is predictable. Many computational systems produce extremely complex outcomes. For example, simple mathematical rules can generate patterns so intricate they appear random. Weather systems, fluid turbulence, biological evolution, all arise from relatively simple underlying rules. Yet they produce outcomes too complex to predict precisely. The universe may work in the same way. A simple set of laws producing astonishing complexity. Now consider something even stranger. Some physicists believe the universe might literally be a form of computation. Not metaphorically, but physically. This idea is called digital physics. According to this view, space and time may not be continuous. Instead, reality might be composed of discrete units. Tiny pieces of information, like pixels in an image, or bits in a computer. In this framework, the universe evolves step by step like a program updating its state. Some theorists even suggest that consciousness might be a process emerging from this informational structure. Your thoughts, your awareness, your decisions could be patterns in the flow of information through the brain. Patterns shaped by physical rules, but still uniquely yours. Now here is the most important realization. Even if the universe follows deterministic rules, even if the chain of causality stretches back to the Big Bang, your experiences remain real. Your thoughts remain meaningful. Your choices remain part of the unfolding universe. You are not separate from the cosmic story. You are one of its most complex expressions. The atoms in your body were forged inside ancient stars. The neurons in your brain evolved through millions of years of biological adaptation. And tonight, those neurons produced the thought that led you here. Listening, thinking, wondering. So was your decision predetermined? Science does not yet have a final answer. Some evidence supports determinism. Other evidence suggests randomness. And the complexity of the universe makes prediction nearly impossible. Perhaps the truth lies somewhere between inevitability and freedom. A universe governed by laws, but rich enough to produce novelty, structure, creativity, and consciousness. And as you begin drifting towards sleep tonight, your brain will continue its quiet work. Neurons firing, memories consolidating, dreams forming from patterns of experience. All part of the same cosmic process that began billions of years ago. A process that produced galaxies, stars, planets, life, and eventually. Thank you for spending this quiet time with Science for Sleep. If you enjoyed this journey through physics, philosophy, and the mysteries of choice, you can subscribe and join us again as we explore the hidden science behind the universe, the mind, and reality itself. One peaceful night at a time. And now, you can rest. Good night.